Hello friend, today we will be discussing about pumping lemma, and I will suggest you to pause the video and just go through the notes that I have given here, and after that we will see the language is a regular language or not, and also it is a context free language or not, by going through one example of each. So I will suggest you to pause it. So first of all, how to check whether the language which is given is regular or not. So first of all, we will take sentence from the language sentence, that is W, and we will assume it as it is a perfect language, that is the regular language. We will assume it. Now we will do this W mod W minus number of times the W occur, and this will be greater than or equal to m, where m is an integer, positive integer. Now after that, W will be divided into three parts, that is x, y and z, and then we will take mod of x, y is greater than equal to m, and mod of y is equal to m, which is greater than equal to 1. Now after doing 1, 2, then we will do the third step, that is we will take the values of I, and uh, remember, the whatever the value we will be taking for I, it will uh, be on y. Okay, it will be on y, such as x, y to the power n, z. So let's see one example. So here we are having a language which is a event palindrome language. As you can see, W and WT. Let's take a sentence from it, that will be W, as I have told you. So W will be, let's take A B B A, and in every A and every B terminal we will be having M, where M is a positive integer. Okay, so as I've told you earlier, so W minus 4m, where the hell we are taking 4m. So how we are taking this? Don't joke. So there are 4 times, we can see here 4 times m is occurring, so we will take 4 times m, which is greater or equal to m. Now W will be divided into 3 parts, there is x, y and z. Now divide the first one into 2 parts and the other one as the single part. So this will be divided into 2 parts, and this whole term will be divided as a single one. So we will be getting the 3 terms here, a b b b a. So this will be 1 1, and the whole will be 1. Now we will be taking the power, where x, y, z will be taking as p, q, and the rest one will get the power of m. So here mod of x, y is equal to p plus q, which is equal to m. Now mod of y is equal to q, which is greater than or equal to 1. Now we'll take the value for the I. Let's take the value for I is equal to 0. Now here choosing I is the most important part for the question, as whatever you will take the value of the I, that will determine whether it is a irregular language or not. So smartly choose the value for the I. Here I am taking the value is 0. Now what happens when we take the value for I is equal to 0? So x, y to the power 0, z. Now as you can see here, this will come here, and here we are having y to the power 0, that is a to the power q to the power 0. So it will be 0. What we are left with? We are left with this and the whole this. So this. Now as you can see here, as I have said earlier, p plus q is equal to m, where uh, p plus q is equal to m, but what we are having here, we are having p is equal to m, which is not equal to m. As why? Because p plus q is equal to m, not p equal to m. Okay, so we are contradicting our assumption. So the result will be it is not a regular one. So our assumption was wrong. As we have done for our regular language, it is similar with that CFL, that is contract free language. For contract free language, we will take a sentence W that belongs to L, we will say, and we will take it as our assumption that it is a part of the language. Then and W, where n is the number of times the W occur, and will be greater or equal to m. Now W will be divided into 5 parts, as it was in 3 parts in regular language. So it will be divided into 5 parts, u, v, x, y, z. Now v, x, y will be less than equal to m, and v, y is greater or equal to m. So we will take again the value for I, and it will be applicable to this, as it was applicable in this here for here we can say for y it was in regular language part, but here what we are having a v y, so it will be applicable on v and y both. So let's see an example. Here we are having the language ww. So we will take a sentence from it, that will be a, b and a, b. So we will be having the power m, where m is, as I've told you earlier, m belongs to any positive integer. Okay, so how many times m occur here? 4 times. So 4m has we saw earlier, and w will be greater or equal to m. So here we are having this. Now the w will be divided into 5 parts, that is u, v, x, y and z. Now w will be, now how to divide this? As in our earlier regular language, we were dividing a the first term. So here we will divide the second term. So what we are having in the second, we are having b, so we will divide b into 3 terms, that is v, x and y. So v, x and y will be this, and the power for the v, x and y will be p, q and r. So we are having a to the power m, p, b, b, a to the power m, b to the power n, and here we are having p, q and r as the power. So the mode of v, x, y will be the mode of v, b, b and b, where p, q and r. So p plus q plus r will be m, which is less than or equal to m. So now vy mod will be b and b. Why? Because v is as you can see here, u, v, x, y, z, the whole is z. So u, v is this, and x, y, so p and r. So we are having p and r. So p plus r is greater than or equal to 1. Now we'll choose the value for I. So we will take I is equal to 0. It will be applicable on v and y. So v 0, y 0 power. So it will be this. I think there shall be no confusion, as I've told you what is u, what is v, what is x, y and z. So so we are left with this, and this will not equal to this will not belongs to the language. Why? Because we are left with q and m. So q is not equal to m. Why? Because we said earlier that p plus q plus r is equal to m. So our assumption was again wrong, and this is not a CFL. Thank you.